So there's optical microscopes. So there's a whole lot of different modalities around optical microscopy, where you can use different dyes and different types of lights that can see through some materials and not others. Electron microscopes. So, and Monash is proud to have some of the most advanced in the world, both with non-biological specimens, but also biological specimens. So the newest instrument at Monash University is called the cryo electron microscope, and that's for cryo. That's for biological specimens. Now, as you can imagine, you have to essentially have to cool them down. But it's producing some of the best imagery you can imagine around the world of biological. The example of Massive itself as a computing platform speeding up the research, I can guess we do volume reconstruction. The imaging beamline used to take days and weeks to collect, to reconstruct the 3D volume data set.
Down to minutes.
And it's down to minutes now. So what, with the beamline of the synchrotron, you had to book well ahead. You had basically 24 hours to go in and put as many things on the beamline as you can, get a picture of it, like taking a photograph, grab all that data and then go away. And from that, you're supposed to somehow reconstruct the 3D volume and so on. Now, anything could go wrong at that stage, and you'd have to repeat that whole visit. With the new techniques, where we're speeding up everything, they check it now while they're in the beamline room. And if it needs a slight tweak, they would change the setting slightly. One of our researchers at Monash makes the comment that research is actually a race. It is a global race because, you know, there's many groups trying to find the cure for malaria, and they're all working on different techniques, so they're on this race. And you know, 50 groups might be actually working towards the same result, but only the first one gets to publish, and only the first one gets the glory. So he's quite serious when he says it's a race. And so anything that accelerates his research, he loves. And so he's obviously one of our champions. He engages with us a lot. He likes us.
I don't know what yet, to tell you the honest truth. It takes weeks, months, years to develop these sort of research codes for them to have real long-term output and impact. But I'm at the moment seeing interest, and so that's a really good sign. The example might be when you do when you use the cryo-EM facility that Paul talked about, the Cryos FEI instrument, you have to look at some of the images, and you have to start to pick out the particles, right? And then there's a machine learning algorithm that takes over and goes, okay, I generally now know what a particle looks like. I'm going to try to get the rest for you, because there's thousands of images, hundreds of thousands of particles. You would never be able to do it yourself.